Hey folks, studying instantaneous rate of change, and I thought I would do a video of one of the, it's kind of a harder problem, a little difficult problem. So let me share my screen with you and get started. This is off of the derivative number 1 sheet. It is the last problem on the derivative number 1 sheet. So actually derivative number 2 sheet, I'm sorry, derivative number 2 sheet. This is one that you did some group work on, and the next page was homework. This last problem's a good one. So I'm gonna try to make a little space here to work on this, and we'll see if we can do this problem. So it says find y prime. That's the derivative of y. Right, y prime is the derivative of y when y equals x times the square root of x plus 1. Okay, so I guess well, no, we'll do we'll do it right here. All right, so we're going to use method B, right? Because we're finding the derivative. You may want to think of this as f of x and f prime of x. That's kind of nomenclature that we've been getting used to, I think. So we might want to think of, instead of calling that y, we might want to call this f of x equals x times square root of x plus 1. This video is going to take a little while. You might want to speed up the video to like time and a half, because I'm usually pretty comfortable to listen to it time and a half because I go slowly. We know we're going to need f of x plus h. So let's just write down what f of x plus h is. Just keep ourselves organized. So remember, everywhere where x is in the function, originally, we're going to replace with x plus h, usually in parentheses, just to make sure. Now, this set of parentheses that I just wrote inside the square root doesn't help us, doesn't mean anything. But the one outside does mean something, because we're not just multiplying the h times this thing in the square root. We're multiplying x originally, and now it's x plus h. Okay, let's start the limit. The limit, as h approaches 0, first we need f of x plus h. Now I look at this and I think, do we want to maybe distribute this out? Distributing out would look like this: x times x plus h plus 1 plus h times x plus h plus 1. And it's important to think about those things and go, well, maybe that'd be better. I don't think it's going to be better in this case, but maybe if you try one and it doesn't work out so well, you go back and try the other one. At least there's an option there. I am going to use this as my f of x plus h. I'm going to use this. Okay. All right. Remember, we're looking for f prime of x. We're looking for the derivative of x. So let's see. The limit as h approaches 0. Top is going to be f of x plus h. Okay, that we wrote down above. That's x plus h, quantity squared, or not quantity squared, quantity, times the root of x plus h plus 1. Okay, and then minus f of x. That's going to be just x times the square root of x plus 1, all over h. Okay, I see these radicals and I think probably want to use the conjugate. So I'm going to write over here what the conjugate is of this numerator is x plus h squared times radical x plus h plus 1. And then instead of minus, plus x times radical x plus 1. All over the same exact thing, right? I'm not going to write that out as long times. I'm just going to write C. I'm just going to write C for the conjugate, okay? The conjugate is the same as this numerator, right? Same as this numerator. That's the conjugate. I'm just going to use C for that and then pull it in later when I actually need it. Okay. So we got to multiply those two things. So that doesn't look too pretty, but it can be done. It's no big deal. You chose a conjugate because multiplying conjugates are easy. So the first term is this x plus h times root x plus h plus 1. And that's going to multiply by the other first term. So there's the same thing. We're multiplying them. That's going to be x plus h squared times x plus h plus 1, right? Because if we multiply the two radicals together, the radical goes away. All right, so that's the first term. Now the O and the I, those are going to go away because they're conjugates. We have that plus and minus sign. We don't need to deal with the O and the I. They go away. And then minus times plus is minus. And then we have to multiply the last terms. The x times x is x squared times x plus 1 is radical x plus 1 times radical x plus 1. So there's the numerator multiplied out. And that needs to be done over h still times c, which is the conjugate, which is that big messy thing, but I'm not going to write that out again. Okay. Remember, our objective here is to cancel out this h. So we're going to hope that something cleans up in this numerator. So we just have to keep plugging away. Just keep doing the algebra. So the limit, hopefully we don't run out of space on the screen. You can just keep turning another piece of paper, but I'm not sure that I can. So let's see. X plus h squared is going to be x squared plus 2xh plus h squared. And then that is going to need to be multiplied by x plus h plus 1. All right, well, that's going to take a little doing. And then minus, this can be distributed. X to the third minus x squared times 1 is just x squared. Okay. And this is that really important minus sign. Everything after that needs to cancel out. And that's all going to be over h times c. Okay. So multiplying these two trinomials together, I find that I make a lot of mistakes doing that. So I'm going to do it this way. I'm going to put x squared up here. I'm going to make a little table. X squared, 2x, h, and h squared. And then down the side, I'm going to put the other thing we're multiplying by, which is x, h, and 1. And I'm going to make a table for this stuff. And I'm going to multiply it and then combine the like terms. So the x gets multiplied by all those things. That's x to the third, 2x squared, h, and xh squared. H is going to be multiplied by all these things. X squared h, 2xh squared, and h to the third. And then 1 is going to get multiplied by the top row. That's really easy to do. X squared, 2xh, h squared. Okay. So it looks like there's a few terms to combine. These two terms combine here, and these two terms combine here, and then I don't think anything else does. So I'm going to rewrite this. I'm going to rewrite this, this limit. I think I'm going to go up the page here. I'm going to go to here. So the limit as h approaches 0. Hopefully it fits here. The denominator is over hc. So keeping track of what that conjugate is, it's still written there. And all of the stuff we just multiplied is now in the box. So let's see if we can string that out. X to the third plus, this looks like 3x squared h, because I'm combining those two boxes. And then plus 3xh squared, I'm combining the next two boxes. And then the other ones just string along. Let's see, x squared plus x squared plus 2xh plus h squared plus h to the third. Then I still have to do, I got to remember to do, let me just highlight this. I got to remember to do this part. All right, so keep going with this. I have to go minus x to the third minus x squared. All right, that's all part of this equation, right? Okay, so some things are going to cancel out now, finally. That's good. I'm going to cancel out in a different color just to make it easier for you to see. So the x to the third gets canceled with this x to the third, and the minus x squared gets canceled with this plus x squared. Okay, then we'll go with another color. I'm going to reduce everything by h, or I'm going to factor an h out. Let me factor an h out. Let me show it to you that way. That's the more proper way to show it. Let me show you factoring h out. Limit as h goes to 0. All right, this first term, we're going to factor an h out of everything. So h in every term that's left. First term is 3x squared. The next term is 3xh. The next term is 2xh. Oh, no, there's only an h there, so we're factoring h out, so there's no h left in that. That's just 2x. And then plus we have h squared, so that becomes h plus h to the third, that becomes h squared, and then we're done. That's the whole thing. That's all of it. All over hc. Okay, these h's cancel. Now we finally do the limit, meaning the limit is h approaching 0. We're going to plug that 0 in for things, and we are finally going to get f prime of x. Okay, so now notice I've been writing the limit all along. It's kind of important to write the limit all along. It keeps track of what you're doing. I'm finally going to substitute 0 in for h, because h is not in the denominator anymore. I can substitute 0 in. And all that's left are terms that don't actually have h in them. So that's going to be 3x squared plus 2x. Notice that, I'm going to highlight these. Notice that this term still has an h in it, which makes it 3x times 0. This term has an h in it, which makes it 0. And this term has an h in it, which makes it 0 squared. So those terms are gone. Zeros disappear. Now we can't forget about our little c down here. So let's put our c in. So we have to still divide by, and then we have to write c in. Now we're also going to substitute h for 0 in here. So that means that this first term, this first beginning part of c is x plus h. That's just going to be x times radical x plus h plus 1, but h is 0 because we substituted in, so that's x plus 1, plus, well, also x times x plus h. Oh, okay. Well, that means kind of there's two of those same things. So our final answer is 3x squared plus 2x divided by 2x radical x plus 1. That is what f prime, the derivative of f, is equal to. All right. I know that's a tough problem, but I also know that you have all the skills to do problems like this, right? You're just applying the limit as h approaches 0 of the difference quotient. And you all can do this. You all learn to do this, not a problem. You just have to be patient and practice. Great job. Thanks for watching the video.